Hello, Explorer. Welcome along. I say it's time that we scoot off planet Earth for just a brief moment and we search out some science secrets lurking through the universe. My name's Dan. It's a brand new Fun Kids Science Weekly. This week, we'll travel back through time and unpack the cosmic collisions behind the moon's craters.
If you have an asteroid the size of London, or 10 kilometers across, it crash lands on Mercury, crash lands here on Earth, or crash lands on the moon, and produces a crater which is 50 kilometers, 100 kilometers, even 300 kilometers across.
And our quest to find the greatest science around sees us looking at the science of impatience. Could evolution be the reason that we struggle to wait?
So impatience is an example where maybe we'd be much better off if we waited for something, but we take the thing right now. So you've got a really nice dinner in an hour, and you're really looking forward to it, and then someone kind of, gives you a snack. You eat the snack, and then dinner isn't so exciting anymore.
And we'll hunt through caves to find bat-eating centipedes. It's all going on in a brand new Fun Kids Science Weekly. Let's start off with your science in the news. Now, nearly 2,000 years after the volcano Mount Vesuvius erupted, scientists have discovered why a young man's brain was preserved. Researchers found the brain in 2020, but not how you would imagine. It was actually as a chunk of black glass. And after some research, scientists now believe that the man was covered in a baking hot cloud of ash that erupted from the volcano. It reached 510 degrees Celsius, and then it quickly cooled down, and it turned his brain into glass, which is why we've still got it 2,000 years later. How mind-blowing is that? Just a few things. One, that this poor lad's brain was turned to glass because of this huge heat way above boiling point. And 2,000 years later, we can do the science to discover why that happened. Just amazing. Also, a private spacecraft has landed on the moon, becoming only the second commercial vehicle to reach the lunar surface. It's called Blue Ghost. It left Earth on January the 15th. It was launched by a firm called Firefly Aerospace with the intention of exploring the Sea of Crises, which is a huge basin visible from Earth. We'll talk more about the moon in just a second, actually. Blue Ghost touched down smoothly. It's been orbiting the moon for the last 2 weeks, and experts have said by going up there we can learn how to run robotic instruments in space and more about the harsh environment of the moon. So we see it's all gearing up for humans to travel back to the moon in the next few years, and genius scientists are doing all they can to make it as safe as possible. And our final story this week, you have the chance to win a brand new competition which wants you to find sustainable solutions to the big problems facing the world. It's the National Innovation Challenge, and here's the thing, you could win an all-expenses paid trip to the USA for it. Let's find out more. Science, TV, book legend Konnie Huq is helping to launch this. Konnie, thank you so much for being there. So, a National Innovation Challenge. What do you want us to create and innovate?
Wow, what we're looking for is a concept, a business idea, or a design prototype that fits in with the theme of sustainable impact. So something that can help make the world a better place to be in. We're looking for young people that think outside of the box, that are creative, that like problem solving or to tackle challenges. And if they come up with a concept that wins, so you have to do it in conjunction with your school, or your place of education. You do have to be actually 12 or over. So anyone listening that's got a big brother or sister and then you feel that you're too young, your parents can still get the opportunity to go with them. And then this is going to be a yearly competition. So in a couple of years' time, they can give you the lowdown and you can enter to get an all expenses paid trip to the USA to visit the Massachusetts Institute of Technology, where some of the brilliant, bestest minds on the planet are. There's a deadline. The entries need to be in by the 14th of March, and all the details are at our website, which is hruc.ac.uk.
It's all about sustainable solutions to the big problems facing the world, Konnie. What are? I mean, we hear a lot about different things, but what are the biggest problems that we can actually have ideas to try and help?
There's so many. I mean, one thing that always gets me is food waste. These big lorries come and they take away your, all your peelings and your waste that you've put in a sort of probably plastic bin. And then the big network of lorries burning their carbon fuel, go and take it to be recycled or composted. And essentially, you could just chuck all those peelings onto your garden soil bed and they would just rot down and go back into Mother Earth, and you don't need any fancy machines to do it for you. So I wonder whether there's an idea. I've often wondered whether there's an idea that you could at home have a sort of mulcher, invent some sort of thing that can take all those peelings and mulch it up so that you can make it into fertilizer and just plonk it down in your local park or your garden or whatever. That's just one idea, but there's lots of other problems as well as food waste. Recycling plastic. Can you think of innovative ways to upcycle or recycle plastic or repurpose something? Because obviously plastic has a high carbon content and we are trying to avoid the carbon gases in our atmosphere. Obviously greenhouse gases are no good for planet Earth. And then obviously there's the problem of keeping our seas and our oceans clean. Maybe you live near a beach and you can think of a way to maybe help solve the problem of pollution in our water. That's another big problem that needs tackling. So there's lots and lots of different things you could do. It could just be something simple as thinking of a way to have more greenery somewhere. We see green roofs, don't we, and green walls nowadays, because every plant, everything, every tree that's leafy and green, they are all helping to create oxygen to help our atmosphere be more breathable and healthy. So maybe an ingenious way to get lots of plants into houses, homes, outdoor spaces. That's a way that you can help bring down our carbon content in our air.
How grand can this be, Konnie? And how makeable does our idea have to be? So you mentioned like a mulcher, something that we could have just in our kitchen. I mean, that's a brilliant idea. It's quite small scale. Would we be up for having something massive that sucks all of the carbon? Would you be up for that?
We'd be up for that. Something big. You could, instead of designing a prototype or making a model of it, you could just draw a picture. You could essentially just video yourself talking about your invention, maybe do a blog. We are open to entries in all different forms. So you can think huge if you want to, or you can think small if you want to do something on the domestic scale, because if every household does something small, then that still does have a huge impact. So it's completely up to you, but something that will help make the world a better place when it comes to the environment.
This is all about getting us to think creatively. Why is creativity such an important skill for young people to really, really harvest?
Because creativity is the way that you come up with new concepts, new ideas to innovate and to change the modern world we live in for the better. Nowadays, there's so much stuff that's done for us already on computers or tablets or smartphones. We have predictive text and we have spell checking and we have loads and loads of different gadgets and gizmos and apps that make our brains sort of relieved of the burden of having to think for ourselves a lot of the time. So it's important that we do still use our brains and nurture our brains to think, because although we have AI and, driverless cars are on the horizon and all of this, they can't think and be creative in the same way as human beings. So that is a very important skill to possess for our future society.
You can find out more hruc.ac.uk. A lot of letters, but for a brilliant prize. Konnie Huq, thank you for joining us.
Thank you so much.
Always good to get a legend on the show. Thank you so much to Konnie Huq for joining us. And you can find out more about the National Innovation Challenge online. And now it's time for your questions. If you have anything sciencey that you want answered on the podcast, well, there's a few things that you can do. You can just keep it to yourself. You can try and answer it. You can do the research. I mean, that's fine. It might take you a little while, or you can do the easier thing, and that's ask me. Drop it as a voice note on the free Fun Kids app. You can send it to funkidslive.com too. I will do all the digging, and I might give a call to one of my genius friends who'll sort it out for you. First up this week, it's from Jack, who wants to know, why is the ocean salty? There's a few things that we need to talk about with this, Jack. Well, firstly, most seawater comes from rainwater. Rainwater isn't salty, so what's happening? Well, as rain falls on the land, it makes its way to rivers that flows towards the sea. On its way there, it bumps into rocks, it runs through mud and over land, it picks up minerals and salt along the way. These come as ions, they're tiny atoms from salts in the rock that the water hits. It keeps going, it kind of merges, it collects all of it and flows into the ocean, which makes it salty. And then in the ocean, there are underwater volcanoes, there are thermal vents way down deep that releases more salt. But then, when water evaporates, you might have heard about this at school, when it evaporates, when it gets so hot that it can't stay as water, it changes state, it becomes gas. That water rises up through the sky as a vapour, and all the salt stays behind. Now, there are some seas which have much more salt in them than others because it doesn't really go anywhere, like the Dead Sea, which is in Asia. It's so salty that if you lie in it, you'll float straight away. You won't bob down at all, you'll just hang there, like in a strange, ethereal cloud. That's what's happening. That's where salt comes from in the ocean. That's why rainwater doesn't have salt. That's what's happening, Jack. Thank you for the question. Let's get on another one then. This is from Matty. It's all about something up in space.
Why does the moon have craters and how were they made?
Well, Matty, thank you so much for your question. Why does the moon have craters and how were they made? Also, we only ever see one side of the moon, don't we? I wonder if we can unpack that too. Let's find out more. Dr. Francisco Diego joins us from University College London. Francisco, thank you so much for coming on. So let's start with the first of Matty's questions. Why does the moon have craters?
Well, Matty, this is a very good question. Actually, the moon is not the only body that has craters. By the time of the formation of the entire solar system, the Earth had craters, and Mercury, the planet, has craters and still has the craters today. The ones on the Earth have been erased because we have atmosphere, we have erosion, we have movements of the continents. But still, occasionally you can see a few craters on the Earth. In Africa, there are some in the very famous meteor crater in Arizona. If you have an asteroid the size of London, about 10 kilometers across, it crash lands on Mercury, crash lands here on Earth, or crash lands on the moon, and produces a crater which is 50 kilometers, 100 kilometers, even 300 kilometers across the big asteroids. And this is how you get the craters on the moon, because of the impact of asteroids that happened billions of years ago. We don't see any today. Sometimes when I look at the moon with my telescope, I expect to see a new crater appearing because a new asteroid has impacted him, but it doesn't. It doesn't happen. We haven't seen any new craters for hundreds of years now, but who knows? We may still see big craters appearing. I mean, smaller craters, yes, we can see smaller craters appearing on the moon all the time, but we don't see them because we need to be in orbit or we need to be very close to the moon to see them.
So we've got these asteroids, these meteors that millions and millions of years ago were hitting the moon. Now, here on planet Earth, we have an atmosphere. That atmosphere, if the worst came to the worst, might help us burn up meteors that enter into that atmosphere. The moon doesn't have as strong as an atmosphere as we do. Does that mean the moon is more at risk of meteors and asteroids than we are here on Earth?
Well, yes, not really. I mean, the atmosphere will protect against small asteroids, if you like. But an asteroid more than a kilometer across, the atmosphere does very little. It will impact, it will crash land. And that was, in fact, 64 million years ago, we had such an asteroid. It was 10 kilometers across and impacted the Earth. That impact caused a massive climate change very quickly, globally, and that made the extinction not only of the dinosaurs, but 75% of the living species at the time. So it was a massive extinction because of that asteroid.
Wow. I mentioned at the start, we only really ever see one side of the moon, don't we? I mean, us on planet Earth, unless we've got satellites and cameras that go to the dark side, we're only ever knowing what's on one half of it. Why is that, Francisco?
Well, it is the way the moon formed. And then I wouldn't call it dark side because the moon receives light of the sun all over. I mean, the sun rises and sets on the moon every 29 days. Is the lunar day. It's a lunar month, if you like, is a lunar day. So the sun rises and sets on the moon, but not the Earth, because the moon is facing the Earth because the way it was formed. If you can imagine that originally perhaps the moon was spinning with respect to the Earth, but with time, and because of the moon and the Earth were formed in a particular way after, again, another collision that happened very early in the formation of the solar system, there was a collision. The Earth was alone, and there was this other planet the size of Mars, more or less, that in a collision track with the Earth, it nearly misses it, but they kind of merged together, and the debris from that collision remained in orbit around the Earth and became the moon. Now, that debris was not exactly the same weight all around it. It was heavier on the side of the Earth. So with time, that spinning of the moon slowed down because the gravity of the Earth was making it slower and slower, and then stopped spinning. The Earth is attracting that part of the moon. And I must say that absolutely all the large moons in the solar system, the 4 large moons of Jupiter, the large moons on Saturn and Uranus and Neptune, they are all facing their planets. They don't spin, which is very interesting. What we call in astronomy is gravitationally locked to the planets. So they don't spin, they just face the planets because of the same reason, because the gravity of the planet is so strong that keeps any irregularity in the distribution of weight in the moon, makes it heavier on one side and then stops spinning after millions of years, of course.
Wow. Well, Matty, there you go. We've answered so many questions about the moon and more than just craters. I hope that sorted out for you, mate. Thank you for your question. Dr. Francisco Diego, hello. Yes.
Yeah, and I must add a little thing, because if you see an image of the moon that we see on this side, that will come in the next few days, we are going to come to the full moon. When you see the full moon, you see a lot of dark areas that we call the seas. And these are lava. They were lava fields. This was molten rock. That were full of molten rock that with time solidified, and then it was because of temperature changes, it was fragmented, and then it became dust, really. So it's like a sand, volcanic sand, if you like. Now that only happens on this side of the moon. On the far side of the moon, I don't say dark side, I say the far side. It's the near side and the far side, because the far side also gets sunlight, so it's not dark. But we don't see it because it's on the other side. But the far side doesn't have these dark areas, doesn't have these seas. It's all solid terrain full of craters. But that's the difference. This is why this side is this kind of I will call it difference between the near side and the far side. It's a consequence of the moon facing us all the time.
Wow. See, I told you, Matty, loads of moon stuff answered. Dr. Francisco Diego, thank you for joining us.
It is a pleasure.
What a thorough answer, Francisco. Great to have you on. Matty, thank you so much for your question. If you have anything sciencey that you would love answered on the podcast next week, make sure you leave it as a voice note for me. You can do that on the free Fun Kids app or at funkidslive.com. It's time for this week's Dangerous Dan, one of my favourite bits of the show. I love looking up some of the weird, odd, unique, and sometimes deadly things that lurk all around the universe. And if you think we've been doing this podcast for years and years and years, and we're still finding more dangerous stuff, this week we're headed into the dark, humid caves across Indonesia to take a look at a centipede who likes its prey pretty big. The giant cave centipede can grow to 10 inches long. It has a body split into segments. It's dark brown and red, perfect to help it blend into rocky surfaces. It has these powerful spindly legs that help it grip to cave walls and ceilings. On its head, 2 enormous venomous pincers that squeeze toxic venom into its prey, which paralyzes it. Now, it hunts in total darkness, so it uses highly sensitive antennae to detect movement and sense vibrations. It hangs from the ceiling to catch prey, climbing high and dangling from its legs. But what is its prey? Why does it need to be up there? Well, this centipede is catching bats. Actual flying bats that get too close. When it's there, the centipede lunges, it grabs its prey, injects the venom, which leaves the bat pretty useless. Now, it doesn't have webs or traps, it just hangs, it senses, and it has to move very quickly, super stealthily, to get its dinner. And that ingenious way of figuring out and interacting, working with its landscape and its environment. The fact that it can take down enormous bats, it means that the giant cave centipede goes straight onto our Dangerous Dan list. Now, for this week on Battle of the Sciences, where we try to discover which is officially the greatest science in the history of the universe. It's a pretty old place, so it's a pretty big task. We're discovering more about why you act the way that you do. Trying to prove why their field should come first is Professor Daniel Reed. It's all about behavioural science. Daniel, thank you for joining us. You have 1 minute to tell us why behavioural science is the greatest science around. That minute starts in 3, 2, 1, go!
Okay, so rather than tell you why it's the greatest science around, I'll just tell you some of the questions that behavioral science can answer, and then you can decide for yourself if it's the greatest. So one question is, why would someone named Dan like someone named Daniel more than they would like someone named Peter, on average? Another question, why do we procrastinate so much? Why do we go along with the crowd, even if we secretly think the crowd is wrong? Okay? Why does your grandfather avoid getting medical tests, even if he knows those tests are good for him? Why do people tolerate cars, but get angry at e-scooters? Why will we work harder to get a $5 discount on a box of chocolates than a $5 discount on a bicycle? Why do people wear designer clothes, even when generic clothes are identical except for the label?
Daniel, that's your minute done, and you've perfectly summed up in a fantastic way the real heart of all of the questions, the secrets of behavioural science. I mean, you immediately got my attention. I am a Dan. I've always been a Dan. You are a Daniel as well, which is interesting. You said why I'm more likely to like you rather than someone called Peter, perhaps. Can you just uncover why that might be?
Well, similarity is a very important determinant of how much we like others. We like people like ourselves. And actually, there's a lot of research showing that we like people with the same name as ourselves more than people with different names. And even to the point that if people with the same name as us ask us to do something, we're more likely to do it.
So you've presented us there with loads of questions which get to the heart of what behavioural science is. But if you were to define it in just one sentence, what is it that you are trying to unpack about humanity with behavioural science?
Well, I think you could say we want to understand why people behave the way they do. And specifically, we are interested in sort of quirks where they behave in ways that don't seem consistent with being completely rational. So impatience is an example where, maybe we'd be much better off if we waited for something, but we take the thing right now. So perhaps you've got a really nice dinner in an hour, and you're really looking forward to it, and then someone kind of, gives you a snack, which isn't that great. You eat the snack, and then dinner isn't so exciting anymore. And you kind of, got less pleasure overall than if you had just waited for that dinner. But why couldn't you? Well, the immediate temptation of that snack was just overwhelming. The fact that it was right now made it super important to you. And of course, that kind of thing can lead us to make lots of mistakes in life. Procrastination, another example where we put off, perhaps writing or doing some homework because we got something fun to do. And then the next day, we really wish we had done that homework.
Daniel, while we're talking about impatience there, I think I've read that you've figured out it's actually to do with our evolution, and the behavioural science through evolution has kind of warped us and moulded us to be a little bit impatient. Why is that? And also, how have you figured that out?
The way to think about it is that we as humans have evolved in a particular environment which is different than the environment that we currently live in. So imagine a couple of 100,000 years ago, living in an environment where food is scarce. They get some food, some fat, and they immediately consume it all, because if they don't, perhaps it will be stolen by another animal or by another human. And so that's the way to survive. And now suddenly you're in a world with Tesco where there's just like food everywhere. There's no shortage of food. You can just eat and do nothing but eat for the rest of your life on one Tesco. And yet you still have the same instincts that evolved for that time way back when the fat and food was scarce.
Now, at the start, you presented us with lots of questions to prove why behavioural science is the greatest. How do you go about finding the answer as a scientist? Because it's not like you're an archaeologist, really, where you can just dig up bones and have a look around. So what are you doing to try and answer these questions?
Behavioral science is largely an experimental science. So we might be interested in why do people have, a certain preference. And the way we would do it is we would put different people into different situations and then see, how do they respond to those situations? And that enables us to determine what features of the situation, determines or, makes them behave the way they do or makes them think the way they do.
Let me throw you forward 30, 40, 50 years, Daniel. We always finish these chats in exactly the same way. At the end of your career, officially in behavioural science, what's the one question you want to answer? What's the one thing you really want to know in your field of expertise?
That's a good question. And I didn't sort of plan for that question. But I think I would like to know whether we can say that people are genuinely irrational, or can we actually understand all of the kind of quirks and unusual aspects of human behavior as being the result of, rational, sensible decision making, but we just don't understand yet the kind of drivers of that action. So are people irrational is a question I would kind of like to have a definitive answer to.
When you say irrational, you mean are we kind of doing whatever we want? Is everything chaos? Or are we making very smart decisions, but we don't understand the consequences of those?
So we might think that people are often making decisions that are bad for them, but are they in fact making as good a decision as they can possibly do given the circumstances they're in? And that would be rational. Irrational would be that, they could make much better decisions. It would be easy for them, but they just are messing up all the time. Yeah.
Wow. What a deep question to try and figure out. It's been a real joy to chat to you, Daniel Reid, Professor Daniel Reid. Thank you for joining us.
Well, thanks, Dan.
We've spoken a lot about the moon this week on the podcast. We heard about a private spacecraft that's landed there. We had Professor Francisco Diego telling us all about moon craters, and we can travel back there now with an episode from our Space Cadets series, learning all about the brilliant things around the universe. This week, Harry and Terry set off to the moon as they try to fulfill their mission as Space Cadets.
Welcome along to the astro adventures of the Space Cadets.
And sprinkle on the cheese and we're done.
Lovely. Top pizza, mate. We just need to cook it now.
What are you boys up to?
We've made a pizza, Zingy.
Yeah, we just need to cook it now. Any bright ideas?
Well, what's wrong with the oven?
Oh, we can't use that. We've got tonight's roast chicken cooking in there.
But then why do you need a pizza, Terry?
Pre-dinner snack. Harry likes his pre-dinner snacks.
Yeah, I need to have a pre-dinner snack, especially before chicken. It's something about poultry, you see, Zingy.
No, I don't really see, but I'm trying to understand you. Is that really ham with pineapple?
Ah, the Hawaiian pizza. One of man's greatest achievements.
Yes, quite.
Guys, I've got some seriously bad news.
What is it, Harry?
I think we've nearly run out of cheese.
Is that it? You have me worried.
It is a worry.
Well, no time for it now. Mission Control have just sent a message through. We're off to the moon.
Fantastic.
Yeah, and we can solve our cheese situation.
Oh, Harry, the moon is not actually made of cheese, you know. That's just an absurd myth.
Really? Oh.
The moon's surface is actually comprised of many different chemical compounds, mainly silica-based, which is found in sand, but none of them dairy-based, I'm afraid.
Oh, I'll put my crackers back then. Still, I can't wait to land on the moon. Isn't the Earth's moon the place where humans first landed in space?
Yes, in 1969, man first landed on the moon. American astronauts Neil Armstrong and Buzz Aldrin were the first men to walk on the moon.
One of man's greatest achievements, space travel.
Yeah, it's okay, but let's not go mad and forget the sheer genius of the Hawaiian pizza.
Yes, Harry. But did you know the moon is the Earth's only natural satellite?
What's a natural satellite?
It's a body or object which orbits a larger body, usually a planet. The moon orbits the Earth every 28 days.
Why does the moon look different shapes at different times when I look at it from Earth?
Well, the moon reflects light from the sun, which is why it can appear so bright. But as it orbits around the Earth, different amounts of the sunlit side are visible. This creates the different shapes you can see: full moon, half moon, crescent moon, and so on.
So what's our mission, Zingy?
Mission Control would like us to investigate an old NASA landing site from when man first landed on the moon in 1969 and report back on what it's like today.
Cool! You excited too, RoboWolf?
Hold tight for landing, boys. We're nearly there.
Wow!
I've positioned the ship just a couple of miles from the first landing site of the Eagle craft from the Apollo 11 mission back in 1969. Take RoboWolf out in the investigation pod and bring back some photos of what the site's like today.
OK, Zingy, no problem.
And remember, keep your spacesuits on at all times. The moon has no atmosphere, so be careful.
The landing site should be just up here. You okay driving, Terry?
Fine, thank you.
It's just the ground's quite dusty and there's craters to watch out for.
I know, I can see them, mate. I'm not you.
Hey! Oh, wow! Terry, can you see that? It's the old landing site. Is that an American flag?
It's a bit battered, but yeah, it is. The Stars and Stripes, the American flag. Neil Armstrong and Buzz Aldrin must have left it here.
You getting photos of all this, RoboWolf? I'm getting out and having a look around.
Yeah. Hey, look at these footprints in the moon's surface. They've survived in the dust all these years.
One small step for man, one giant leap for... RoboWolf, come back here! We need you to take more photos of the site.
What have you found, boy? Harry, look at what RoboWolf's found. It's an old NASA moon buggy. It must have been left here.
Oh, wow. Does it still work?
Harry, it's not going to still work.
You were saying? Mate, there's two of us. We have an investigation pod and now a NASA moon buggy.
Dude, are you thinking what I'm thinking?
I know. The Hawaiian is definitely the most underrated pizza.
No, not that. No, I think we should have a little race.
Oh yeah, let's do that. Let's start at these footprints, go round the crater over there, and finish at the old American flag.
Sure. I want the NASA moon buggy. It looks speedy.
OK, I'll take the pod. Get lined up. RoboWolf, can you start the race, please?
OK, RoboWolf. Ready when you are.
Go!
I'm going to beat you, Harry.
Come on, then. Hey, watch out. We're on the edge of the crater here.
I'm going to win, Harry. This NASA moon buggy is super speedy.
No!
Ah!
Terry! Are you okay, man?
Yeah, I'm fine. Oops, the tyres burst. Probably shouldn't have driven it so fast.
Do you think this is what Zingy had in mind when she said investigate?
I don't know. Hope so. Come on, let's get back to the ship.
Welcome back, boys. How was it?
Oh, Zingy, it was amazing. The flag's still there and the footprints and everything.
Fantastic. NASA will be happy. Sending copies of RoboWolf's photographs to Mission Control now.
And RoboWolf even found an old moon buggy too.
Incredible. Well done.
Yeah, it looked like it was in pretty good nick too.
Yes, all spacecraft and vehicles are built from the highest quality materials. Well, except for my old ship. Spaceship cutbacks, that is. That moon buggy will probably stay in one piece for many more years. Harry, why do you have a moon buggy wheel under your jumper?
Oh, this? It's a souvenir? Join us next time for more Astro Adventures with the Space Cadets.
You can hear more from the Space Cadets wherever you're listening to this. We've got loads more podcast series for you to enjoy, for you to explore the universe with on Google, Apple, Spotify, on our app, and at funkidslive.com. And remember, if you're subscribed to Fun Kids Podcast Plus, you've got loads of episodes and tons of podcasts completely ad-free. Find out more on the Fun Kids website. Fun Kids, we're a children's radio station from the UK. Listen all over the country on the app, on our website, and if you've got a smart speaker, wake it up and ask it to play Fun Kids. Right, we've landed back down on Earth. So I will see you in a few days for a brand new Fun Kids Science Midweekly. I can't wait.